Hello everyone, I am Cyril and welcome to my first video here on YouTube. In this video I'd like to do a brief overview of the project I'm currently working on, Harmonizer 01 for SuperCollider. So without further ado, let's get to it. So what's behind Harmonizer 01? Harmonizer 01 is a rule-based system that uses backtracking to resolve a progression of chords into a 4-part harmonization according to classic harmony rules. It achieves this by collecting chord data from a static library of MIDI note ranges. It then filters those ranges so as to gather valid candidate notes for each of the voices to then be used during the backtracking process. Harmonizer 01 is also a personal research project that aims at exploring how different algorithms can be used to generate music, and in this case in particular harmonies. Although I'd love to extend this idea in the future to other domains of music such as counterpoint, rhythm, etc. This is also an ongoing project that I'll be developing for the foreseeable future as I explore different algorithms and techniques to achieve this goal. And it also ties with the creation of this YouTube channel as a way of documenting this journey. Finally, the ultimate goal of this project is the materialization of my experiments and research into a series of SuperCollider classes capable of handling harmony generation in a live setting. So what does Harmonizer 01 do? Harmonizer 01 works by calling on the function harmonizeProg with two mandatory arguments, progression and durations, where progression is an array of symbols and duration is an array of numbers, of either float or integer type. Both arrays must be of the same length. The function then returns the harmonized progression in a multidimensional array that stores both the MIDI notes and durations for each of the voices. Harmonizer 01 has also a sustain parameter that allows for common tones to be sustained rather than repeated. This is done by removing succeeding MIDI note duplicates within each voice while adding the corresponding durations. So by setting sustain to true we get Now let's try changing the sustain parameter to false. Harmonizer 01 also has a direction parameter to change the melodic contour of the upper voice, the options being up for an upward motion, down for a downward motion, and line for a ranged motion. It also has a score export option that exports the progression to a sheet music editor compatible with the Python module Music21. In the previous examples, direction was set to its default value of line. So let's try the value up with score set to true. Okay, so now let's try down with score set to true. How does Harmonizer 01 work? Harmonizer 01 is comprised of a series of subsystems, of which the most important are the parsing system, the range system, the rule system, and the backtracking system. In the next few videos I'll be exploring these systems in detail with the code, but for now let's go briefly through each one of them. The parsing system is responsible for breaking down each chord from the progression into meaningful data, such as the complete chord cipher, the chord type, that is, whether it's a major, minor, augmented, or diminished chord, the root of the chord, and the root distance from the previous chord root. This information is then used to assign a rule profile to each chord that will take effect during backtrack as new chords are generated. The range system manages MIDI note ranges for each of the chords. This is achieved by gathering the data from a static library of MIDI note ranges. The system then assigns valid candidate notes to each of the voices based on their own registers. If the rules apply, the range system is also responsible for filtering out notes from each of the vocal ranges that violate valid melodic intervals or to enforce common tones being sustained. These two checks are done given a previous chord. The rule system has in its core a series of Boolean flags that determine which rules are to be enforced. These flags affect the following scopes: parallel movement between voices, meaning parallel fifths or octaves. This system does not currently check for hidden octaves or fifths. Chord position, so whether the chord is in root position, first inversion, or second inversion. Note duplication. Since we're working with triads in a four-part harmonization, it checks if the note being repeated is the root, the third, or the fifth. Voice spacing. If the distance between the voices is within bounds. Common tones. If common tones within a voice are to be respected. Melodic intervals. If melodic intervals within each voice are valid. And voice crossings, whether or not a voice is allowed to go over another voice. The rules are enforced through a series of checker functions that operate during backtrack, asserting the validity of the generated chords or progression. The backtracking system is comprised of two nested backtracking processes. The inner process generates all valid chords for each of the ciphers. The range system is called before this process to gather four series of candidate notes, one for each of the voices, to be used during this process. And the rule system sets the rules to be enforced before backtracking the chords, and then checks if the generated chords are valid. The outer process uses the generated chords as candidates to build a progression. The checker functions that assert the validity of the progression are still being developed. Known issues and current limitations. Currently, Harmonizer 01 only supports triads. That's because in order to reduce the scope of the project so that it didn't become too complex and overwhelming, I chose to rely on a static library of triads. The idea was to focus this version on the rule and backtracking systems, and then on the next iteration of the project, expand on that and include a complete library of dynamically generated chords. Certain progressions do not get solved. In rare instances, I still get the error message, Harmonizer 01 was not able to solve the progression. That will be fixed over time as improvements are made to the backtracking system and as the rule profiling for each chord gets fine-tuned and more comprehensive. I'll be listing those progressions so that I can test them again in the future. So if you come across a progression that does not get solved, please pass me that information along with the argument settings used. The score export does not reflect user-defined durations and sustain notes. The score export was created as a testing aid that allows me to see the generated progression in score rather than just as MIDI values. It will be extended in the future to reflect other user-defined parameters such as sustain and durations. Depending on the size of the progression, computation can get slow. Although it's generally fast, in certain cases and depending on the progression provided, the program might take a little bit longer to solve the progression. The backtracking system in its current form is a bit too expensive and will need revision. Better rule profiling will also help. So, what are the next steps? I'm currently in the process of cleaning up and testing the existing code. A lot of the systems already have unit tests, but not all of them do. I'm also lacking a systematic collection of progressions to be used in testing, as well as a list of progressions that are currently not being harmonized. I'm also in the process of writing a series of wiki pages for the repository with additional documentation about the project. Once these steps are complete, I want to move on to improving the rule and backtracking systems to achieve better results and hopefully make the program more efficient and faster. So that's it for today. My next videos will be about the various systems, starting with the parsing system next week. I'm kind of new to video making, so I hope this video wasn't too bad, but let me know in the comments what you think. If you enjoyed the video, if you find it interesting, any suggestions or comments are more than welcome. And finally, if you'd like to support my channel, like, comment and subscribe, and I'll see you in the next video.